Okay, so we are now on to Lab 2, the Humpty Dumpty and Drought in the Hudson Valley. And we're going to do this lab just like we did the last one. There's a few parts to it, and I'll make a separate video for each part. This lab is supposed to take somewhere around 180 minutes of your time, so I believe that I have allotted about 3 class periods for that. And then we have some makeup work time after that. So you'll have plenty of time to get this all done. And I'll be walking you through it every step of the way as well. So whenever you click on Lab 2, if you go over here, and I think this is the page where your link will bring you to. Click on Part 1 because this section right here is just an overview and some background information on Humpty Dumpty Talus, and you don't need to worry about that. So just go straight to the Part 1, exploring the Humpty Dumpty Talus slope. In this activity, you will focus on a region that has areas of loose rock called talus interspersed with strands of shrubs and trees. The site ecology at Humpty Dumpty Talus Slope is very important because the rocky terrain results in very little soil buildup, and the trees have limited access to water. As a result, these trees grow very slowly, in some cases just 0.02 inches per year. For comparison, your nails can grow 0.12 inches in a single month, so that is very, very slow growth. The size of each annual ring depends on very much the amount of rain that fell during the growing season, because this affects soil moisture. Scientists describe these trees as stressed or climate sensitive, meaning that their ring widths reflect their ring widths reflect the conditions of the growing season every year that the tree is alive. At Humpty Dumpty, a dry summer will result in a narrow ring, and a wet summer will result in a wider ring. Watch the video of dendrochronologist Dr. Ed Cook describing what makes the Humpty Dumpty a valuable site for studying past climate and what drew him into the area for many years ago. What can we learn by studying the growth rate of trees in this region in the New York State? Once you've finished watching the video, answer the questions below. So we're going to be answering 4 questions based off of this video.
My name is Edward Cook. I'm the director of the Lamont Minority Earth Observatory Tree Laboratory. Well, the Humpty Dumpty Talus Slope is located on the Mohonk Mountain House property. It's a very famous resort hotel established in after the Civil War by the Smiley family, 2 brothers who were Quakers. I had taken courses in dendrochronology out at the University of Arizona, and I knew what to look for in terms of arid site or xeric site trees that would be useful for climate reconstruction. What drew me to the Humpty Dumpty Talus Slope site was the occurrence of white pines and eastern hemlocks growing on this talus location in an extremely xeric situation. In other words, there was no soil development there. The trees were very stressed by limitations of available soil moisture for growth. And that's what really kind of caught my eye when I first saw the site. So I gained access to the Humpty Dumpty area, not far from the hotel, through a happenstance meeting I had with Dan Smiley, a grandson of the founders of the Mohonk Mountain House. And he gave me permission to walk around the place, explore for trees and things like that. And that's when I found the Humpty Dumpty Talus Slope. Well, the first thing that caught my eye were the white pines growing there, and they look quite old. It's hard to find old trees in the eastern United States because of long time cutting history, cutting of the forest. So what I noticed was that one of the trees in particular had a classic spike top growth form with a bit of a twisted trunk, and I cored the one white pine and found that it was over 350 years of age, very, very slow growing. The 350 years of growth in the tree rings would give us information about changes in rainfall, moisture variability, occurrence of drought in the past, because again, these trees are growing on a site where there's almost no soil moisture storage there. They rely almost strictly on what falls from the sky for moisture that allows them to grow. Well, the forests up at Mohonk Lake and actually all through the Hudson Valley are being severely impacted by various insect pests. The most serious one is the hemlock woolly adelgid, which is literally wiping out the hemlock there completely. there still are residual pockets of living trees, but they're being hammered very badly by the adelgid. And I would say maybe even within 10 years, there won't be any hemlocks there at all. So one of the premier tree ring sites in the eastern United States will disappear as a consequence, the one based on the hemlocks anyway, at Humpty Dumpty Talus Slope. It's really quite a tragedy.
Okay, so what initially drew Dr. Cook to this area to do tree ring research? Well, this guy, Dan Smiley, a naturalist and owner of Mohawk property, gave Dr. Cook permission to explore the region. And Dr. Cook knows that there was a group of white pines and eastern hemlocks in a very dry, slow-growth area, the Talus Slope, and he thought that could be useful for climate reconstruction of the Hudson Valley. Question number 2. Why are the trees on the Talus Slope ideal for use in tree ring research? So remember, we want to use trees that are living in a very harsh environment. So these trees are growing in very poor and limited soil, with limited soil moisture and little water available for growth. That causes the trees to grow very slowly. It results in annual rings that are very sensitive to changes in summer moisture conditions. The white pines and hemlocks are ideal for study since they are so old and growing in harsh environments. When coring, Dr. Cook found trees that were about 350 years old, which is quite old for this area. So long climate records could be developed based off of that. And it's kind of crazy to think that a tree would actually want to grow in that type of an area, given that it is so hard. How do the seeds even find a place to take root? Number 3, what did Dr. Cook hope to learn from the trees growing at Humpty Dumpty Talus Slope? He hoped to find long-term record of climate in the region by analyzing the old white pines and hemlocks growing on the Talus Slope. Changes in rainfall, moisture, and availability, and the occurrence of drought in the regions could all be determined. And number 4, what is threatening the health of the trees at the Mohawk site? So the hemlock woolly aglid is disseminating the hemlock forest. There may be no hemlocks in the region in the next 10 years. Right-click on the link below to open a new window to see a 360 view of Humpty Dumpty Talus Slope. And then describe the site conditions you encounter in recording other information, such as the site coordinates. It is important first step in any research expedition. These descriptions and data set the stage for your research and are also information that would be used in scientific publication about the site. So we're going to be able to answer this next question, question number 5, based off of that. So we were just describing. We've already described this area before. You can look at it again. There's a lot of walking trails through here. So how do you describe the Humpty Dumpty Talus Slope site? Be sure to emphasize the types of vegetation you see, how many different types of trees, shrubs, etc., the density of that vegetation, the soil or lack of soil, the presence of water or absence of water, and any other characteristics. So, for starters, this area is very rocky with only a few types of trees that I can see. I see a tree here. It looks like there might be a tree over there. This is some trees here. Down there might be a lot of trees, but not in this particular area right up here. The density of the trees is sparse since there's little to no soil or subsequent soil moisture available for the trees. Outside the Talus Slope area, however, are dense strands of conifers and deciduous trees. So that's talking about this area over here, but right in our current view, there isn't really much. Nothing can really grow, on here. You got a random tree up here, but you don't see, the lush forest that you see down there. Now let's compare this site to a nearby but very different site. How might different environmental conditions alter the growth pattern of trees in the climate record they reveal? Right-click on the link to open the window and take a close look at the enchanting pond. So I'm going to exit out of that one. And we're going to be answering the question, how would you describe the Enchanted Pond site? What are the differences between the two sites? And we're going to be emphasizing vegetation that you see, density of the vegetation, soil, water, anything like that. Oh, wow. Okay, so there's definitely, ponds. There are many types of trees. You can see that the colors are changing on some of the leaves. Looks like we have conifers and deciduous trees. These are definitely a lot of hardwoods around here. You can see that there are some grasses. There are some water plants as well. There's some lily pads in there. It looks a lot more dense here. Wow. Looks very serene here, very pretty. Looks like there's a lot of soil as well, as opposed to being embedded in just rocks. So the trees are going to grow a lot faster. And even if there's a drought, they should be all right. They're not going to be as sensitive to the climate change because they'll be able to store water, especially from this pond. They'll be drawing water in through there. There's a large number of trees and grasses as well. And question number 7, how do you think these two different environments affect the growth of the trees and the seasonal rings produced by both over dry and wet seasons? So let's think about what we know as far as how trees grow and what we know about their rings between dry and wet seasons. When trees have a constant supply of moisture, their growth rings are going to be wider. If they don't have a lot of moisture, then that's going to be those skinny little rings. The trees in the Enchanting Pond are going to grow much faster than the Humpty Dumpty trees, and they're going to be less sensitive to the climate because they do have a source of water normally. Trees growing at the Enchanted Pond would not be really of interest to scientists interested in the paleoclimate. Trees on the Talus Slope, however, would be much better as recorders as far as what the rainfall was like during that period of time because they grow so much more slowly. Instead of having only 40 or 50 growth rings, trees at the Talus Slope are going to have 300 or more, and they're able to stay alive longer because they are shorter trees. They're smaller. And watch the video below. Listen to Dr. Ed Cook describe how serendipity often plays a role in science. And then we'll be answering our last question based off that video.
My name is Edward Cook. I'm the director of the Lamont Minority Earth Observatory Tree Ring Laboratory. The way I met Dan Smiley was through what he was a very fond believer in serendipity, the chance occurrence of things that develop into something far more important than you would have ever imagined. And, I had sampled some pitch pine on the conglomerate slabs up in the Shonga Mountains. And I wanted to look at the ringworth variations and compare them to climate data. I looked around and I found out that there was a cooperative weather station up at Mohawk Lake that was established by the Smiley brothers in 1896 and had been continuously run since that time. And Dan Smiley, a grandson of the founders of the Mohawk Mountain House, had taken over the duty of recording the observations, temperature, and precipitation at the Mohawk Mountain House where the instrumentation was located. So I go up to the guardhouse, the gatehouse, thinking that, well, maybe I can get a hold of some of this climate data, not knowing Dan Smiley at all. So I went to talk to the guard there, and I said to him, I'd like to see if I can get some climate data to compare tree ring widths. And he said to me, I know just the person you want to talk to. And he called up Dan Smiley on the phone from the gatehouse, and Dan invited me up to his home. And we talked for about an hour, and then that's how it all started, really. It was just by chance that he was there in his home, and he was always so curious about nature and like that he found this kind of an interesting project that I was involved in. I spent many years working with him, and he was an old school naturalist who just recorded everything. He was fascinated by nature, and so this was all another story that he could look at to try to understand the history of environmental change at Mohawk Lake, which was what he cared about. The meeting with Dan Smiley in 1971 up at Mohawk Lake made all the difference in the world for me. if I had just said, thank you, Dan, and I never went back to work there at Mohawk Lake and to work with him over the years, I would have missed a massive opportunity to continue the research there. So I think you have to be able to take advantage of the serendipities in life, that provide you windows of opportunity for conducting, interesting research, that you find to be the kind that you really want to follow.
Okay. So we have one question left here. And what role did serendipity play in Dr. Ed Cook's work near the Mohawk Mountain House in New York? It was a chance of meeting and a subsequent friendship with Dan Smiley at the Mohonk Resort and Lake that launched his research at the Humpty Dumpty Telescope. So that is it for part 1, and I will see you guys back here. We're going to click on the next page, and that is going to take us on to part number 2. As you can see at the top, we're looking at coring trees and observing ring patterns.